Hi everyone, welcome to DT's premiere where technical drawing is made simple. Please like, share, subscribe, and hit that notification bell to support the channel and help reach more students. Let's begin. So for this drawing, we're going to learn how to draw a quadrilateral equal in area to a re-entrant pentagon. And what that means is that the pentagon has one side that is greater than 180 degrees. So it's an irregular polygon. So the question is on the left and we'll be drawing on the right. For those who have the book, you can follow along. And the book's name is Technical Drawing 1 Plane and Solid Geometry by A. Bankole or S. Bland. And we're currently on page 36. And afterwards, we'll be moving on to page 37. Alright, so first things first, we need to read the instructions, and it says to draw the pentagon given that AB is equal to 80 millimeters, BC 100, CD 70, DE 40, EA 80, and the angles CBA, EAB 120 and 45 respectively. So this is the image, or this is what the pentagon is going to end up looking like. So that's A, B, C, D, E, and going back to A. All right, and we'll be reducing this. So while I'm reducing, I'll explain how we actually reduce a pentagon. So if you get another question like this, something similar or not too far off, but not quite the same, you can do it on your own. So first things first, we need to draw the line that is our base, or the baseline. And the baseline right here is AB, so we need to find AB. And AB is equal to 80. So that's the first thing we're going to draw. We always start with our construction lines. So I'm going to switch over to construction line, turn on my ortho, and draw 80. Next thing I'm going to do is label. So I'm just going to copy one of these, turn off ortho so I can move it, and label A, move it, and then label B. Next thing I need to do is to find the angles that are constructed at A and the angles that is supposed to be constructed at B. So CBA is telling us that the angle is 120, EAB is 45. So for the angle that should be at A, that's going to be 120. So center, start, end. And we are going to draw our semicircle going all the way around. All right, it is 120, which means I'm pretty much going to get a, oh, sorry, my bad, it's going to be 45. EAB is 45. All right, so let's continue. That's my error. So starting here using the same exact measurement I did before, which is 10, cutting this. So this is now 60, but 60 is not what we want. We're going to create a 90 and then bisect it to get the 45. So we're just going to do this again from here, come over by 10, and once this is done, we can use these two new points to get our 90-degree angle. All right, so now we have our 90 degrees joining A to the intersection at the top. We're going to bisect this to get our 45 degrees. So center, start, end, where the 90 intersects the semicircle. I use 10. You can use another figure. It doesn't have to be 10. You're not limited to only using 10. But once you use 10 on one side, you have to use it on the other side. All right. Draw a line to the intersection. Now, the next thing we need to do is to establish our 120 on this side, which is the angle CBA. So center start N again. I'm using 10. I'm going to use 10 again. Center start N. This is going to give us 60, but we do not want 60. All right. So all I'm going to do is just mirror this on the other side. So I highlighted everything and I'm grabbing my mirror command. I want to mirror these two things. So I highlight it, press enter. Using this as the center of my mirror because I want this to be on the other side. Just click, turn on my ortho to ensure it's going in a straight line and select the screen. You just click right there. It will ask you if you want to mirror. Yes. So now our 120 is on the other side. Save. Alright, now that we have our two angles, we can establish the sides via the length. So we look for lengths that have are connected to A, so AE, and are connected to B, so BC. So let's look for AB, AE or EA, and BC or CB. So currently BC is 100. So center start N. Do a little swing test to see where our extension is going to go to know where you're going to start drawing your arc from. Well, that's what I usually do. Remember to turn off ortho. This is what happens when you don't turn it off. So ortho, going up 100, enter. Extend this line, but we want it to extend up, so we have to extend closer to the top. Then now AE, let's look for AE. It's the same as EA and that's 80. So here, the little swing test, I'm starting right here. 80. Then extend. Alright. Now these 2 points are new points and they actually have a name. So this point is called E. Let's label that. And this point is C. DE is 40. So we go for your center start N. For this one, we aren't sure where it's going to be. So you just look at the image and kind of judge it. All right. And then DC or CD is 70. Where they meet, you draw lines. And this is our RE-ENTRANT pentagon. All right. No, you can do either one of two things. You can go ahead with the instructions, read it carefully, and do it on your own. Or you can do it along with me, and I'm going to explain why we do what we do. All right. So first and foremost, we want to reduce this pentagon to a four-sided figure or a quadrilateral that's going to have the exact same area. All right. So the first thing we need to do is to get our first parallel line or establish the first parallel line that is going to allow the rule of the parallel lines and the diagonal lines to come into place when it comes onto area. And that is to get it from the highest point, let me use a different color, from the highest point of whatever shape is there. And this is a pentagon, and the highest point to me when I look at it is at D. All right, these I and C. So you start your parallel line from the highest point and then to the lowest point on the same side. All right. So highest point D, lowest point A on the same side. Then now we need to establish a new parallel line, right? This line needs to be parallel to the one that we just drew from the point that is in the middle of the two. All right. And the point that is in the middle of the two would be at E. So copy, and it's parallel. So we didn't draw a line, we copied the previous line. Then trim. Now we trim because this line is actually supposed to stop exactly on our straight line or on our horizontal line AB. And then let's label this point F. So if you're reading the instructions, you'll see where it says to do all of this as well as to label the point as F. Then now to reduce it to our quadrilateral, which is the same exact method you use for reducing it to a triangle and so on, is to draw a line that goes from the highest point of the previous parallel line to the lowest point of the new parallel line. So highest point of the previous parallel, lowest point of the current parallel. When we highlight all of these sides now, we can now outline them, and this is our quadrilateral. Alright, so I'm changing all of these to outline and I'm extending this. And this is how we get our quadrilateral. Now there's another part of this question, and that's the reason why I have 5A instead of just 5, that wants us to further reduce this quadrilateral to a triangle. So if we were asked to reduce the pentagon or any shape at all to a quadrilateral or to a triangle, we would first have to reduce it one size at a time or one side at a time. So one size at a time, one side at a time. So the first thing we did was reduce it from a 5-sided polygon to a 4-sided polygon, then to a 3-sided polygon. All right, so this is the instruction to reduce a quadrilateral equal in area to a triangle. All right. So in order for me to allow you to understand, I'm just going to copy this or copy. Let me copy just the quadrilateral and bring it over. For you, if this is easier for you to do, get the quadrilateral first and copy it over, no problem. But usually you do it on the same diagram. So if you get the pentagon and they say reduce it to a 3-sided figure, you do it on the same thing. Reduce it to a quadrilateral, then reduce it to the triangle. However, if it's easier for you to do it the way I'm doing it, by all means, go ahead and do so. So I'm going to call this B and change the title. So to draw a triangle equal in area to a quadrilateral. All right. So now that we have that, let us just copy the labels and put them back. So the quadrilateral is now F, B, C, and D. And I want us to practice the same exact thing that I told you. All right. Instead of doing it on this side this time around, it's not going to work out. And I want you to understand why it's not going to work out. It's because if you should go from the highest point to the lowest point over here, notice the line is going to actually be in line with DF. So you don't actually get a parallel line that is going to work. So we just switch it to the other side. All right. So from the highest point of your quadrilateral to the lowest point of your quadrilateral, which would be from D to B. Then you're going to copy your parallel line and place it at the point in between. Now, the point in between could never be F, because when I select F, notice my line falls under. You want it to fall beside it, all right? Or somewhat beside it, so C. Now, this leaves me only one option to extend my line and then trim. Because remember, it needs to be on a flat or a plane surface. This part is now going to be called G. And then the diagonal would be from the highest point of the previous parallel to the lowest point of the new parallel. Now, after this is done, we can outline all the important parts of our drawing, which makes our triangle. All right, and this is how we reduce from a pentagon to a quadrilateral to a triangle. I hope you understood. I hope you learned something. If you have any questions, leave it in the comments or send me a WhatsApp message. Have a good day.